Hello, welcome back to Educator.com and welcome back to physical chemistry. So today we're going to talk about Joule's experiment. Let's just jump right on in. So recall in the last lesson, what we did is we said that energy was a function of both temperature and volume, and we created this total differential expression we had, which was du equals du dt sub v dt plus du dv sub t dv. And in that lesson, we associated this particular thing with the constant volume heat capacity under constant volume. So now the question is, so we took care of this, we associated it with some easily measurable quantity. Now, what can we do about this? That's the question here. So we're just going to deal with the other partial derivative in this total differential expression. So what can we do with that? As it turns out, the answer is not much. So a little bit disappointing, but it's actually, we'll be able to say a couple of things about it. But the truth is, we can't really do much about it right now. So let's talk about this thing that this Joule's experiment. So let's go ahead and draw out what it is that he did. So he came up with something very, very ingenious. So this is going to be water. And of course, this water, there is a thermometer in it to measure its change in temperature, things like that. And there's a little stir in here to make sure that the water is stirring up well. And let me go ahead and draw this little apparatus in here. And let's go ahead and put okay, so this is A and this is B, and I'll go ahead and sort of shade this one in. Okay, so basically what the idea is this. We want to find out, so remember du dv, we want to find out if there is a change in volume, what is going to be the change in energy? Because that's what this derivative says. It's the rate of change of energy as, with respect to volume. Per unit change in volume, how much does the energy change? So basically what he did was this. He took this apparatus, which consisted of this two bulbs separated by a stopcock. We evacuated this chamber altogether, this B, and A is filled with this gas. So basically what we do is we take this thing and we drop it into this, tub of water, and we allow this to come to thermal equilibrium, the system to come to thermal equilibrium with its surroundings. When that happens, what we do is we open up this stopcock. Because it's evacuated, this gas is going to expand. So it does experience a change of volume. And then upon this change of volume, we allow the system to come to thermal equilibrium again, and what we do is we measure the temperature change of the water. So that's what we're doing. We're seeing if there's going to be some energy change based on a change in volume. We're trying to measure this. We're trying to, what is the relationship between a change in volume and a change in temperature, which is a change in energy. And here's what actually happened. Okay, here is the result. No change in temperature. It was a bit surprising. The expectation was that you would open this up, the system would undergo a volume change, there would be a temperature drop or a temperature rise, and then heat would either flow in or out, and that heat flow in or out would be measured by this. That would give us a change in energy versus a change in volume.